today I'm going to tell you the most important things you need to know about natural gas, one of the resources that provides cooking and heating and electricity to our energy services. So, in honor of natural gas, I've got my drilling earrings on because that is how we get it out of the ground. So, let's dig into natural gas. So first, you should know that natural gas is a leading resource both in the United States and the world in terms of our energy needs, especially for heat and electricity production. And it's been a growing resource in the United States. So we're seeing that growth of natural gas both in the United States and worldwide. The United States is now actually the largest producer and consumer of natural gas in the world, but you can see that both production and consumption really have been growing all over the world. So let's talk about what is natural gas. Natural gas is a fossil fuel, meaning it is a hydrocarbon that we're getting energy from burning that hydrocarbon and breaking those hydrogen and carbon bonds. It is the simplest and cleanest fossil fuel. So here, the primary component of natural gas is methane. It's our simplest molecule. It's one C and four H's. Oil is kind of in the middle. It's got longer chains of hydrocarbons, and coal is kind of more like a mass of different networks of hydrocarbons. It's one of our solid fossil fuels. And being the simplest means that it has the lowest carbon intensity of any of our fossil fuels. So we get more energy out per greenhouse gas that we emit. And it also doesn't have a lot of the contaminants that we see in things like coal, which has a lot of sulfur, heavy metals, things like that. So we often talk about natural gas as the simplest and cleanest burning of our fossil fuels. Natural gas, like our other fossil fuels, was created from biomass that was squished over a long periods of time. So in our crust, it's squished, has time, temperature, and pressure. Think of that as like the pressure cooker that's creating that natural gas. The origins of natural gas are many. It can come from the same origins as coal, which are like our swampy materials, the same origins as oil, which are like tiny marine organisms and other biogenic resources. So natural gas can be associated with coal or oil or found by itself. And so talking about some of those key terms about natural gas, one I just mentioned, associated or non-associated, that just means whether the natural gas we found was by itself or is it associated with oil production? So it's coming out as we're producing oil. We talk about whether natural gas has sulfur content and talking about whether it's sweet or sour. So sour means it's got a high sulfur content, sweet means it has a low sulfur content. That matters because we want to get the sulfur out before we burn our natural gas, because when we burn sulfur, we form sulfur dioxides, which contribute to acid rain. So we try to take sulfur out of our fossil fuels. The other key term to think about with natural gas is whether it's wet or dry. It has nothing to do with water. There's not water content in our wet natural gas. What that means is that we have something called natural gas liquids. Longer chain hydrocarbon, not quite as long as what we'd consider oil or petroleum, but more complicated than that methane. And so some natural gas that contains a lot of these other components like propane and butane and things like that, we call it wet natural gas. Natural gas has a variety of uses very different from our other fossil fuels. Oil is really a transportation fuel. Coal is primarily used for either industrial heat or electricity production. Natural gas is used in all of those sectors. So we really do see that natural gas is used in residential, commercial, industrial, electricity production, and transportation, all of those areas. Now, when we first started finding natural gas, we didn't want it. Natural gas is a gas. It makes it a very low energy density. It's hard to transport unless you have pipelines or some way to liquefy it. It's hard to deal with. So the first way that we dealt with natural gas when we found it, usually associated with oil, which is something we really wanted, was we would either vent it or flare it. But we started to realize that it had a value in its own, and then consumption of natural gas has grown since then. And so it's gone from this kind of booby prize, something we didn't want, to really something that is the cleanest burning fossil fuel and the one that's growing the fastest today. In the United States in particular, which again is the #1 leader in natural gas production and consumption in the world, our natural gas production really opened up with the horizontal drilling and hydraulic fracturing revolution, where we really found more resources of natural gas. Before this, before the mid 2000s, we thought we were going to run out of natural gas in the United States. We were ready to import LNG. But with this technological revolution, we had a lot more domestic natural gas and has really opened up production in the United States. So when we do, how does the system work? What we do with natural gas, obviously, we're drilling for it, we're producing it, we're gathering it often in pipelines. Don't have to do a lot of processing with natural gas, just a little bit of removing sulfur, and then we can distribute it to consumers, either industrial or residential consumers. It's usually transported via pipeline if you have pipelines available and it's over land. That is the cheapest, the easiest, the most efficient way to transport natural gas, which is a relatively low energy density fuel. But obviously, over the ocean, we cannot transport it via pipeline. So we do something called liquefied natural gas, or LNG, where we're compressing and cooling that natural gas so that it is in a liquefied form that then we can load onto ships and transport it. This process is very energy intense. So it takes a lot of energy to cool and compress that natural gas into liquefied natural gas. So you can imagine that we're using some of that energy just to liquefy it in this process. The United States is actually now one of the leaders in LNG transportation. A lot of this is going to Europe, where Europe has done a lot to try to reduce its dependence on natural gas from Russia. And this is a growing space. So we're seeing LNG terminals go in place all over the world, both import and export terminals, in order to accommodate this high production we have in the United States and the transport of it to other countries. So just talking about it being the number one exporter in LNG, you can see the growth in LNG as we've had this horizontal drilling and hydraulic fracturing revolution that's really made us the top producer in the world. So in terms of the environmental impacts, I mentioned that methane or natural gas is the cleanest burning of our fossil fuels. And that's when you're burning it. So it is much cleaner in terms of when you're burning natural gas than something compared to, like, say, for example, is coal. But methane itself is a very potent greenhouse gas, 81 times more potent than CO2. And so when you leak any of that methane into the atmosphere, you're basically mitigating that greenhouse gas benefit. And only a small leakage, estimates range around 3%. If we're leaking 3% of the natural gas that we're utilizing in our system, then we're offsetting that greenhouse gas reduction benefit. And so methane leakage is one of the big challenges with natural gas use that really needs to be managed in order to have a decarbonization benefit with using natural gas over something like coal. Methane is released from all sorts of other things, not just our natural gas system. So what I'm showing you here is how big a piece of our greenhouse gas emissions is methane, where it's emitted. And you can see natural gas is about a third of our methane emissions, and much of that is on the production and distribution side of things. So more needs to be done on methane leakage. We are getting better at assessing where methane leakage is happening. So methane is an invisible, odorless gas. So we often have to add things to it even to be able to smell it. If you smell methane emissions, like in your home or something, you're actually smelling an additive, something called mercaptan. It is not naturally something that emits any sort of odor or can be seen visually. So we've had to use a lot of other tools, and now we have a satellite system so we can truly measure where some of the worst leaks of methane are happening so that we can target those and reduce those methane emissions associated with our natural gas use. Natural gas prices can be pretty volatile, just kind of like we see with oil. They used to follow oil a lot. Now they're kind of have their own volatility. And that's going to be due to weather, due to supply disruptions, due to demand changes, due to technology changes. We see a lot of variability in natural gas prices, both due to locationally and globally. Finally, just thinking about what is the future of natural gas, there's a lot of variability and predictions on this, but we have not reached peak natural gas for sure in terms of demand. Demand is expected to continue to grow in at least the near future. All right, so that's kind of the big picture things you need to know about natural gas. If you want to dig more into it, check out natural gas on our website. We've got some great videos and readings you can check out and our full lecture. And definitely check out our Energy Spotlight. We've got some great topics coming to you from there.